In this video, I'm going to talk about some high-level aspects of Ansible. Now, the general thing I'm trying to do here is to try to convey to you some of the reasons Ansible is structured the way it is. And that's going to help you in the long run when you try to construct Ansible scripts that perform various operations on network devices. So if we think back a little bit historically about how Ansible was built and how it intended to operate. So the way Ansible is fundamentally built is you have this Ansible control machine, which would be some variant of Unix for the control machine. And then it would ship out using SSH. It would basically bundle up a module, and in general these modules would be created in Python, although it doesn't necessarily have to be this way. But you would bundle up this Python module, you would ship it to the remote machine via SSH, and you would count on it being executed here on the remote machine using SSH. So if we think about this, we're using the SSH channel to ship out this Python module. The Python module gets executed on the remote machine because the remote machine has Python. It then ships back JSON as the output, and that JSON gets shipped back across this SSH channel. Now, there's some caveats to this. It doesn't necessarily have to be a Python module. It could be anything really, it can be something else as long as it outputs JSON, but in general, they're Python modules. Now, this all makes sense in the context of when you're working on, a Linux, Unix control machine, and you have Linux, Unix servers that you're managing. Now, if we start thinking about networking devices, so in the context of networking devices, you can't really, even though a lot of networking devices are built on top of Unix, there still is sort of a walled garden between the Linux of the networking device and the networking operating system. So even if the networking device has Python on it, even if you could actually ship across using SSH a Python module and execute it on the device, you still might have a lot of problems in how do you talk to the networking operating system. So in the vast majority of cases with networking devices, we don't actually try to use an on-box Python. We don't just ship some module remotely and try to execute it there. Instead, what we do is on the Ansible control machine, we basically ship the module to itself. We ship the module just directly back to the Ansible control machine. And this Ansible module that's bundled up is just a bunch of Python code. Remember, with the caveats I said, it doesn't necessarily have to be, but almost always it is. That Python code then executes on the control machine. And what does that module do? In the context of networking devices, that module, the code inside there, will then actually execute the SSH or API connection. So for legacy devices, you'd be talking SSH. It would go log into the router CLI, it would do some screen scraping operations, do whatever it needs to do. It would get its get its data back, and then it would output JSON back to the Ansible control machine just locally here. For newer networking devices that have a reasonable API, you don't necessarily have to connect via SSH. You connect via this API. You do the operations that you want to do. Once again, you get your JSON back here to the control machine. So it's important to remember that Ansible is inherently expecting to be this distributed system. It's inherently expecting to be shipping things to remote machines and getting JSON back. We're not really doing that with networking devices. really with networking devices, we are having the modules all execute locally here and then directly connecting via the module to all these remote devices. So yes, it's still a distributed system, but all the module execution is happening directly on the control server, and then built into the module are all these API and SSH connections to networking devices. Now, I have up here this Ansible underscore connection equals local. That is sort of the keyword that we're going to be using in Ansible to basically tell Ansible that, hey, don't ship these modules to a remote device. Instead, ship them back to the control server. That's how we're going to basically make that happen at the Ansible level. And sometimes you're going to mess this up and forget to do this, and you'll get an Ansible error because it's actually trying to ship the module to the remote machine, and it can't do that properly. It can't execute the module properly on the remote device. It fails. You get back an error. So this is this high-level context of how Ansible is originally supposed to operate, and then how we operate in the context of networking devices. Now, if we move on and we start talking about what do Ansible scripts actually look like. So if we start looking at an Ansible script, let's look at the high-level structure of an Ansible script. So Ansible scripts are known as playbooks. In Ansible, you're going to write your scripts in YAML. So if you remember our discussions about YAML, you're going to start with 3 hyphens. Here I have my 3 hyphens. Now, there's different components to an Ansible script. The highest level component inside the playbook is this thing known as a play. Remember in our YAML discussion, you'll see that this starts with a hyphen and a space. And you should remember from our YAML discussion that that indicates a list entry. So here's list element 0, this element here. Here's list element 1, this element here. And we could have more list elements beneath it. That would be play 1, play 2, play 3, etc. for however many plays we had in it. Now what the heck is a play? A play is some combination of machines we're going to operate on. So in our context, generally network devices we're going to operate on. And then things we're going to do. Some set of tasks that we're going to operate on these machines. So here you see the components of this play. I have a name. Remember, this is a key value pair. Here's the key, name. And here's the string associated with that. In Ansible, the name key just indicates an identifier and a message that gets printed when you execute the script. So when you execute your script, you're actually going to see this string get printed. Now, here is the set of hosts that this play is going to operate on. In this case, it's a single router, PyNet router 1. Now, we get down below it and we see this tasks keyword. So here's our key, tasks. And then inside the key, inside the task, you'll notice another YAML list. You see the space, you see it's indented inside of it. And this keyword here is actually the Ansible module we're going to execute. So here I have the host I'm operating on, PyNet router 1. Here's my tasks, and I could have multiple tasks. Here I only have one. Generally, with a given module, you would have arguments over here. In this case, I only have, I don't have any arguments. It's just going to basically try to talk to this router and give me a response back. And then here's my second play. It also has a single task. So if we zoom in on this a little bit, here I have my hosts, which I'm pointing to. And then here I have the Ansible module that I'm executing. In this case, the Ansible module is named the ping module. We're going to be working with a whole bunch of Ansible modules in this class. They're going to have various names. As I said a few minutes ago, they generally have arguments associated with them. So it's important to recognize where the Ansible module is being called in this playbook. And you can think of it somewhat like a function call in Python. The name of the function we're going to call, and then generally a set of arguments. So now if I go back to my shell window and I look at this test ping.yaml module. So here's basically the same playbook that I was looking at a minute ago. YAML file, here's my 3 hyphens, here's my play1, here's my play2, here's my name string, my host, and then the task. Now, how do I run this script? How do I execute it? I just do Ansible playbook test_ping.yaml. Now in my lab environment right now, I haven't put my inventory file in the standard location, so I'm just going to manually specify my inventory file. The inventory file is where you store information about the remote device. So in this case about PyNet Router 1 and PyNet Router 2. We'll talk a lot more about inventory in a little bit, so I'll go over inventory, different ways you can store inventory, but for now I'm just pointing to the file so it can find it. If I go ahead and execute this, the script runs, you see it runs okay. I'll add a -v flag just so we can see the output a little bit clearer. That just turns on some more verbose. Notice here I get the output back. So if we look at the top, so here's the name. So that was the field that I specified with the name : it said ping PyNet Router 1. Here's the actual module being executed. Here it ran correctly. Notice here I get JSON back. So JSON comes back to me, and then here the second play executes. Once again, I get JSON back. Now there's also a way in Ansible you can run and execute modules straight from the command line. So here I'll show it to you. So here I say Ansible. Now it's not Ansible -playbook, it's just straight Ansible. And then I say PyNet -router 1, i.e. the host I'm going to get execute against, the module that I'm calling, the ping module, and then I specify my inventory file. And it'll just show you that output directly. If I wanted to change the host, I could say PyNet -router 2 module ping and ping the PyNet -router 2. You see it came back successfully. You see it outputs it as JSON.